Okay, so you just watched the video, the number file video. What did you think? What did you learn from it?
So it's a pretty neat way to, I think it was to tell that if a game is winnable or not.
All right. How do you do that?
So you look at the genus of the number. So if you have a graph, and something like this, you look at the vertex, I think it was vertices minus the edges plus 1, or what, and then
Yeah, that
Yeah.
no. Yeah, that's what they were doing.
That's what they were doing.
so
They
that's
called this the genus of the
genus.
graph.
All right.
And then the amount of money you put on the board has to be then more equal to the genus.
Yeah, so you have to have at least as much money as the genus
So in this
on the board
case,
in
you
order
have
to win.
so you have 4 vertices and 4 edges.
Okay.
So the genus is 1.
Yeah, it's actually edges minus vertices plus 1, but for this example,
It doesn't really-
But the edges and vertices are the same number. It's fine.
Yeah.
So
But that's okay.
the genus is 1. That means you have to put more than that on the board.
Equal to or more than.
That.
Ah, interesting.
So
All right.
if you had an example like -1, 2, 0, and then another -1, this wouldn't work.
That would not work.
Yeah, because you have 0.
Uh-huh.
And then you can't. It's less than the genus.
All right.
That equals 1.
But why don't you change one of the numbers to
So say if
to make
you
it the sum be 1?
that. Even if you just made it 0.
Okay. And how would you win this game?
So let's see. I think you start. Let's see. That's a 0 again. They also.
That's not winning though.
Oh, that's not winning.
All right. How do you win?
Now you can't.
So they were actually playing that you can give money that you don't have.
Uh-huh.
So like this, so that you can always donate money even if you don't have that amount of money.
Okay.
So for example, we could take this 1 down to -2 and give like this, and then
Fire to there as well.
oh, that's 3, so I should go down to minus. There was a 1 before.
Yeah.
A -2.
Okay.
So you have this. So then this 2 could fire
0.
to 0.
And you have -1.
Yeah, 2.
And then you just.
And then you fire again. 0. 0. And 1.
Okay. Good. All right. That's a good example. Is there anything else? Anything else you learned, or you haven't had a chance to say anything about the video yet?
Well, it said that not all graphs with the same number of points are solvable. Like, they had an example. Oh, I'm gonna erase this. So they had an example where they had a graph like this, and it went 1, 0, -1,
Mhm.
and this is solvable. And then they had one like this, where it went 1, 0, -1, and this is not solvable.
Okay. And what's interesting about this?
Well, you've got the same number of points, but it's not. You can't solve this.
Okay, interesting. So what's different about these two graphs?
You had a vertice connecting this and that.
So you
So
have
it'd be like that.
Okay.
and so the genus is increased. So you need to have more money in this graph to start to be able to win
Yeah.
than you do up here.
Okay. Anything else you want to say?
Well, they said you can prove whether you can do it or not, but you can't prove how many moves it will take. They haven't figured out how to prove that.
Oh, interesting. Does it at least make sense that that would be harder, finding an
Yeah.
optimal strategy?
There definitely is an optimal strategy, but it's harder to find.
Oh, why do you say there definitely is an optimal strategy?
Well, there's a rule that I remember where with games where you know all the information, then there's an optimal strategy.
Interesting.
Like checkers or chess or this game.
Yeah, and the optimal strategy is just hard to find.
But the big games where you don't know all the information, there's not an optimal strategy, but this falls into the first category.
Yeah, sort of. The thing you're remembering is for two-player games, but
This is more of a one.
yeah, but you're on the right track. You're on the right track. All right, cool. All right, good work, guys.